Now, if we look at most circle, at point O is the center of the circle. To go through point X to point Y on the circumference, what is the angle of rotation? Repeat again. If you look at point X and point Y on most circle, right? If I want to get point X to go to point Y, or the relative angle between point X to point Y, where the center is at O, the angle is what? 180 degrees. Now, let's look at the element. If we look at an element, point X to point Y is how many degrees? Right? So what does this mean? We just link most circle to the real world. It means if the angle over here, right, is 180 degrees, on most circle is what? Sorry, I'm not going to draw the direction of the arrow. It can be confusing. Wait, okay, I'm just going to put in the angle, right? So we know that this is equal to 180 degrees. This angle over here, how did it do that? This angle over here is what? 90 degrees. So i.e. on the element, if it's theta on most circle is equal to what? 2 theta. I can go to 2.5 pages of derivation for this. What's the point? Okay, I don't have a lot of time left with you guys. 2.5 more weeks. And then we are done. Okay, I've seen you guys more than you have seen your parents for the past 12 months. Okay, am I right? Right? Freaking 2Q04, fucking 5 hours, and this 4 hours, 9 hours of I mean, yeah, I see you more than you see mommy and daddy. Sometimes a good thing. But mommy and daddy will not be impressed what I've been teaching you. Right. So what we have done now is this distance over here to here. This is your what? Tau max. Okay. So the next thing that I want to let you know is we are going to call 2 points. Okay, where I'm highlighting now. This is my stress 1 and this is my stress 2. Now, there's no reason I label it that way. It's like why my mom and dad call me Eugene. Are we clear? If you want the left point to be stress 2 and the right point to be stress 1, go for it. Okay, there's no reason for it. Okay, have fun. Okay, because I tried reading the textbook, why didn't I label this way? I got nothing. So now we are going to determine stress 1 and stress 2. They are known as principal stresses. Okay. Principal stresses states that the shear stress is equal to what? 0, which is true. The shear stress at at stress 1 and stress 2 are equal to what? Are equal to 0. To calculate the principal stresses is so straightforward. It's plus 40 plus or minus 50. So this will be equal to, so you can have minus 10 megapascal, and over here you can have 90 megapascal. For this stage, this is known as your stress max, and this will be known as your stress what? Mean. I don't agree how they label stress max and stress mean, and let me explain to you why. Okay. This is a different example. If let's say in situation number 1, your compression is at minus 180, your tensile is at 50. Can someone tell me which is stress max and which is stress mean? Yeah. Yeah. So this is your stress mean and this is your what? Stress max. But if your stress allowable is at, for example, is at plus minus 90 megapascal, what are you going to say? The structure failed with its minimum stress. Ta-da! Stupid, isn't it? I have to follow the textbook. Okay. Right. So remember, it's just laboring, okay? Don't kill yourself. Accept it as facts, okay? Don't like fight it. Some things you fight, a lot of things you don't. This is one of the things that you don't fight. Right. So the next thing we're going to calculate is the principal plane. So the next thing we're going to calculate is the orientation of the principal plane. Okay. So this is usually labeled as theta. Okay. Theta in the real world. Okay, theta in the real world. So over here, x to the principal plane, you have to rotate by 2 theta. Now you understand why it is 2 theta, yes or no? Right? You can rotate from point X and or you can rotate from point Y is also equal to what? 2 theta. No difference. You want to put point X. Now, the principal plane is on this line. Okay, the principal plane is on this. The principal plane is on this line. Okay, the principal plane is on this yellow line over here. Why the principal plane is on the yellow line is because the shear stress is equal to what? Over here, the shear stress on this line is equal to what? Equal to 0. Okay. So now we are going to find 2 theta. So very basic math that's required. What we specify is tangent to theta is equal to what? It's equal to 30 divided by 40. And then 2 theta is equal to 30 divided by 40. Make sure your calculator is in degree mode. 36.9 degrees. And theta is equal to 18.4 degrees. Okay. So that is your angle. Yes. That is on the element. Yep. Okay. Are we clear? Okay. Now, from here comes the hardest part. A lot of even engineers, right? You calculate all this already, and then you don't know how to bring it back to the. Whatever you do, you have to be able to think how to bring it back to the what? The real world. Not all subjects. Some like this, you have to. We are doing structure for now. Okay. If you are doing electricity, maybe not. Okay? But you're doing structure, you have to. So it's 18.4 degrees, and it's going in what direction? If you look at the direction, 18.4 degrees is going in what direction? Clockwise. Okay, you put clockwise. So what does it mean? Okay, so next, we know that our stress 1 is equal to what? Stress 1 is equal to 90 or minus 10 and stress 2 is equal to what? 90. Okay, so we know that. So now we are going to construct an element or construct this line over here. And then we know what? The rotation angle is clockwise 18.4 degrees. So we're going to take a protractor and we're going to sketch this. We're going to sketch at 18.4 degrees. So 18.4, I only can see 18 or 19. This is 18.4. Okay. I'm going to copy, I'm going to paste, and then I'm going to rotate this thing by 90 degrees. So we know that this has been rotated by 18.4 degrees. With here, from here, we are going to draw an element, sketch. And then when we sketch an element, the next thing we're going to do, we are going to find where point X is and point Y. So we know that this orientation over here is our point Y. And this orientation here is our point what? Point X. Right? So if X were to rotate to this surface by 18.4, what is the stress? Right? If X were to rotate that angle at 18.4, what is the stress? So you go back to your mole circle. You look at point X, it rotates by 2 theta, and this is in tensile by what? By 90 degrees. So you draw this going through tension, and this is your 90 degrees. And then on the other side, same thing is on compression. This is 10 minus 10, or you can just put 10 megapascal. So what have you learned today? You have learned the following. Okay, you have learned how to find normal stress or how to find stress average, principal stress, shearing stress, orientation of the rotation, or determine the principal plane orientation, and then lastly, the most important, you know how to transfer the data from element to mole circle, and then after that what? Mole circle back to what? Okay. Friday, we're going to do another example of 2D mole circle. Then we're going to go to 3D. 3D mole circle is just 10% more difficult. Or 10% more difficult. Okay. Yes, welcome to the and go to your other class.